we're exploring what is artificial intelligence and how does it work. My goal is to explain AI in everyday language, using examples you encounter daily without drowning in technical jargon. Artificial intelligence might sound like science fiction, but it's already part of our lives. When you ask your phone's assistant a question, get movie recommendations on Netflix, or see personalized posts on social media, AI is at work behind the scenes. At its core, artificial intelligence means that a computer or software performs tasks requiring human-like intelligence, like understanding language, making decisions, or solving problems, by using algorithms and large amounts of data. Through these algorithms, AI systems learn from data and improve over time, resulting in programs that perform specific tasks very well. Consider a few everyday examples. Your email inbox automatically filters out spam. Your phone camera recognizes faces. Navigation apps suggest the fastest route. And banks detect suspicious transactions to prevent fraud. From virtual assistants in driverless cars to medical diagnosis tools and intelligent game characters, AI is everywhere. So how does AI actually work? Traditional programming involves writing step-by-step instructions for every action a computer should take. In AI, instead of hard-coding every rule, we provide the computer with vast amounts of data and let it learn patterns on its own. There are 5 main stages in developing a typical AI system. First, gather a large, relevant dataset. For instance, if you want an AI to recognize cats, collect hundreds of thousands of cat photos, as well as images without cats, so the system can learn what isn't a cat. Next, clean and prepare the data. Raw data is often messy, incomplete, or full of errors. During this phase, you filter out noise, fix missing or incorrect entries, and convert everything into a format the AI can process. Remember that garbage in, garbage out. If the data quality is poor, the model's results will be unreliable. Then comes model training. This is where the magic happens. Using a chosen learning algorithm, you train the model by showing it examples paired with the correct answers. In our cat scenario, you label one set of images as cat and another set as not cat, allowing the model to internalize the patterns that distinguish cats from other objects. After training, you must validate and test the model. Feed it new, unseen examples to confirm whether it truly learned to recognize cats accurately. If it performs well on this fresh data, the training is successful. Finally, once the model reaches the desired performance, you deploy it into a real-world application. For instance, embedding it in a photo app that auto-tags cat pictures. The training process doesn't necessarily end there. Many AI systems continuously learn from streaming data, becoming more accurate over time as they consume fresh inputs. At every stage, data is the lifeblood of AI. Just like humans learn from experience, AI models learn from data. The quantity and quality of data determine how smart the model becomes. Within the AI field, 2 subdomains frequently come up: machine learning and deep learning. Machine learning encompasses techniques that let computers learn from data without explicit programming of every rule. It powers everything from email filtering to medical diagnosis. Deep learning, a branch of machine learning, uses artificial neural networks that mimic the brain's structure. These networks are called deep because they have multiple layers of interconnected nodes. Deep learning excels with large datasets. For example, it can distinguish cats from other objects with exceptional accuracy because it can learn highly complex features on its own. 3 fundamental concepts underpin AI development: the algorithm, the model, and hyperparameters. An algorithm is like a recipe. It's the step-by-step method the computer follows to learn from data. A model is the brain that emerges after training an algorithm on data. When presented with a new input, say a photo, the model outputs what it has learned, such as, yes, that's a face. Hyperparameters are settings chosen before training, like learning rate or number of layers. They are not learned by the model, but heavily influence how well it learns, much like oven temperature and baking time influence the outcome of a cake. Where do we encounter AI in everyday life? Search engines use AI algorithms to find the most relevant pages among billions in seconds. Recommendation systems on streaming platforms or e-commerce sites learn your preferences to suggest movies, songs, or products. Image recognition powers features like face detection and portrait mode in your smartphone camera, and social media platforms use it to tag friends automatically. In gaming, AI-controlled characters behave intelligently, and in manufacturing, robots optimize production lines. In health and finance, AI assists doctors in diagnosing diseases and helps banks catch fraudulent transactions. Despite its power, AI has limitations. It isn't a conscious mind. It only works well in domains it was trained for. A music recommendation: AI can predict songs you might like, but it doesn't understand music's emotional or cultural significance. If training data contain biases, the model will reproduce those biases. For example, a model trained only on red apples may fail when it encounters green apples. An AI system for hiring trained on biased historical data can perpetuate discrimination. Therefore, developers must use fair, diverse datasets and maintain human oversight. Moreover, AI isn't a magic wand. Simple, rule-based programs can be cheaper and more efficient than full-fledged AI solutions in some cases. Only use AI when it genuinely adds value to the problem at hand. Let's address some frequently asked questions. Is machine learning the same as artificial intelligence? No, machine learning is a subset of AI. All machine learning applications are AI, but AI also includes rule-based systems and other approaches beyond machine learning. Is AI truly intelligent or just programmed? AI learns statistical patterns from data, creating the illusion of intelligence, but it has no consciousness or emotions. Will AI take people's jobs? AI can automate routine tasks, but more often it works alongside humans, enhancing productivity and creating new job opportunities. Human creativity and social skills remain irreplaceable. Can we trust AI? AI systems can make mistakes, especially when trained on incomplete or biased data. In critical fields like medicine, human experts must review AI outputs. Is it possible to build a simple AI application on my own? Absolutely. Online courses and libraries such as TensorFlow or PyTorch make it easier than ever. With basic coding skills, you can build a digit recognition model or a small chatbot. Every expert starts as a beginner, so dive in and experiment. To recap, AI enables computers to perform tasks requiring human-like intelligence by learning from data rather than relying on hard-coded rules. The development process involves data collection, data cleaning, model training, validation, and deployment. Within AI, machine learning and deep learning play distinct roles. Key concepts include algorithms, models, and hyperparameters. AI appears in search engines, recommendation systems, image recognition, gaming, robotics, healthcare, and finance. Yet AI is not infallible. It has limitations related to data quality, bias, and lack of genuine understanding. It's not always the most cost-effective solution, so use it judiciously. Thank you. I hope I've helped you understand what AI is and how it works. Until next time, take care and stay curious.